Today we're going to take a look at making the Siren circuit in Fusion 360. And the Siren circuit is showing on this document right here, along with a few notes. Just going to scroll down so you can get a look at all of the notes here. And this is a little circuit that will go whirr, whirr. Every time you press S1. It's going to charge up C3 down here. C3 is going to turn on this capacitor here. They're going to vibrate back and forth in there, triggering the speaker. And as the voltage in C3 slowly discharges after you release the switch, you're going to hear the frequency drop off until the speaker stops making any sound at all. And S2 over here is just your main power switch. The battery, switch 2, switch 1, and the speaker are all going to be mounted off the board, so they're only going to be connected by leads. And just a note on here, we have an NPN transistor and a PNP transistor, so two different types of transistor on there. You can replace them with any standard NPN or PNP bipolar junction small signal transistor. So a 2N2222 is going to work just fine in there. A couple of things to note, as I say in here, when we're going to be mainly using items from the Adafruit library in Fusion 360, but that is an add-in library. You do have to add it to your list of libraries. But I'm very disappointed with Adafruit. They didn't give us the right symbol for non-polarized capacitors, or at least if they did, I couldn't find it. Maybe they're disappointed in me. So here's your circuit diagram. Here's all your values. Go ahead and create the circuit. Now, if you get stuck, that's what this is all about. So here's my tutorial on how I'd go about making it. So the first thing that I'm going to do is I'm going to open up Fusion 360 and I'm going to come to the electronics design. So you come in here and you tell it new electronics design. And when you tell it that, bang, you've got this right here. So your electronics design pops up right in here. And the first thing that we're going to do, well, we can get rid of the mechanical design in the background. So we've got the tab all to ourselves, is we're just going to save that. And I'm going to save it in the same folder I was working on my Winky Blink, another project earlier on. I'm just going to call this one Siren. And the location it's being saved to is Winky Blink. Some people might like to create their own Siren folder for it. I'm fine with that. I'm just going to throw a lot of these little projects into one folder because they're all kind of Winky Blinks in their own right. All right, so I've got my project file, which is going to keep my schematic and my board linked together. So now I'm going to create a new schematic. And my new schematic pops up right in here. And before I do too much else, I am just going to save that as well and make sure that it knows that it is called Siren. There we go. So the Siren project and the Siren schematic are both in the same folder. We'll create the board for it a little bit later on. Let's get around to adding some components now. So we're going to add a part. And as I mentioned, I've added the Adafruit library and the battery library into my system already. If you need to do that, you can open your library manager and go ahead and add those libraries in. The first part that we're going to add is the NPN transistor. And I've already done some poking around so that I know that if I search for NPN underscore TO92, that an NPN TO92 transistor is going to come up. Now, it's always important before you place any model into your drawing that you check to make sure that the schematic symbol is right, that the footprint makes sense, okay, and size matters, so double check the size, and that any notes down here you might want to follow up on. I don't think there's anything in here that we need to be particularly worried about, so let's go OK. And then we're going to place that NPN transistor kind of right in about here on our diagram. We'll go, okay, we don't need any more NPN transistors. Let's add a PNP transistor this time. And again, we're going to add PNP in the TO92 package. The TO92 refers to this shape. There's lots of different components that come packaged in a TO92 package. So let's go ahead and open that up and go ahead and place that. And looking at our design, that comes right about up here somewhere. We can move it around later on if we need to. The next thing that we're going to add is the film capacitor. And a little later on, we'll talk about how I found all the parts and everything. But what I found is probably the best size for a typical film capacitor is C-US 050-02. Now, I don't want to type all the rest of it in. I'm just going to put a star at the end of it. And that means anything after this point that matches will be fine. And I'm going to come up here and look under CUS. And there we go. I've got 024 time, and you'll notice that the main difference between the 024 times 044 and the 025 times 075, the footprint is is exactly the same in terms of where the holes are, but the outline of the part is just slightly different. So we'll say OK, and we'll go ahead and we'll pop that in there. And we want to rotate that a little bit so that it's facing in about right here, and C2 goes right in about there. And zoom in a little bit on that if we need it. Now, this was the part I was talking about that I'm a little disappointed that Adafruit didn't draw this flat side, or this side flat, because that is showing that that's an electrolytic or a polarized capacitor, and this is not a polarized capacitor, it's a film capacitor. So anyways, we will forgive them because they did give us a nice set of libraries for free. So I can complain or I can do something about it, and right now I'm going to do neither and move on to the next part. So now we're going to add a push button switch, and switch underscore push. And again, I don't want to type it all in, so I can put a star in there. Now, it should automatically do the wildcard searching for me. A few different options come up right in here. I don't want this one because it doesn't have the through hole points, and that one will probably do the trick, and again, no through hole points. So I've got the right schematic symbol right here, and because I'm mounting this up and off the board, I really don't care that much about the footprint, but these two holes, few millimeters apart, is going to be perfect for soldering a couple of wires into for mounting a switch somewhere else onto the chassis of our project. So we can go ahead and we can put that in, and that switch is going to be somewhere up here. Okay, let's add another part. And what are we adding now? We just had the switch in there. Let's try the battery, and the battery AB9V. And the battery comes in here. We'll rotate it. Again, we want to make sure that the positive side is facing upwards, and we'll slap it in right over here. Okay, and after we've added the battery, we can start adding some resistors. So let's see in here, add some resistors, and if we just tell it we want resistor. Now, for some reason, the search function is not working particularly well here, and it's forcing me to go in and look at a whole bunch of things. Now, I tend to like Adafruit's resistors, and so I'm going to take a look right in here, and Adafruit, you've got some resistors in here somewhere. P, Q, R, RUS. So there we've got a resistor symbol, and here we've got a nice footprint, and you want to take a look at that and say, okay, how big is a typical resistor anyway? So I find a typical quarter-watt resistor, which is the resistors that we tend to use in the shop quite a bit, is about 10 millimeters long, 1 centimeter long. And so this part right here, 0309/10, should work fairly well. If you want to give yourself a little bit more space, the footprint next to it is just a little bit longer. That might make your soldering go a little bit easier. On the 10 millimeter length, you really have to bend the corners around. If you're trying to run a bunch of wires underneath something, you can go for a longer length still, but the 0309/12 part right here, 3 millimeters by 9 millimeters with 12 millimeter spacing on the pins, should work out really good. So let's go ahead and say OK. And we're going to use this for all of our resistors in this project. So we've got one resistor that's going to be coming in right here, one resistor that's going to be coming in right here, one, let's rotate these into the vertical orientation, one resistor coming down right in here, another one coming in right in here, and another resistor that's going to come over here between the transistor and the speaker. So if I count that right, that's 1, 2, 3, 4, 5 resistors. 1, 2, 3, 4, 5 resistors. Okay, so we've got some resistors in the right spots. And now we're going to add some aluminum electrolytic radial capacitors. So let's come and click on here. And so can minimize that. And I suggested a couple names that we can look for. There's also C-Pol for polarized capacitors, and C-Pol US. We can tell it we don't want the surface mount devices. Now, that should have filtered out the surface mount devices. Tell you what, I figured out the name for this already anyways, and it is C-Pol-US E2-5. And there we go. So this comes up right here, and this does have the correct symbol for a polarized aluminum electrolytic capacitor. It's also got about the right size and pad spacing for a small capacitor. So anything in the like 22 microfarad and under category for radial aluminum electrolytic capacitors should work right in here. The diameter is 5 millimeters, and the grid, the spacing between the pins, just over 2 millimeters. Works okay with the parts that I have in my shop, probably work okay with the ones in yours. And we're going to use this for both of our capacitors because they're both pretty similar in value. We're going to pop one in right here, and we're going to pop another one in right over there. Let's see, now that leaves us with the speakers and the on-off switch. So let's add a speaker and speaker. And seeing as how the speaker is being mounted off the board, we don't really need that footprint in there. It's going to occupy a bit of space on our board, but it's fairly small, so I'm not going to worry about it too much. And our spacing right here, about 5 millimeters in between the connections. I can live with that. Again, I might design my own part and design it to meet up with a 2-pin header or something like that. But there we go. We'll pop that speaker in right down there, and we'll click OK. And then we will add the SPST switch. So we'll search for SPST. And if you want, you can add a star at the end of it to make sure you get anything that says SPST. And this one is designed more as a push button switch. Ours is going to be more of a toggle switch, but this gives us the 2 holes, and we're going to wire it up on our case anyway. So this should work out just fine. We'll ignore the rest of the footprint. Later on, we are going to take a look at making our own libraries and making our own parts for those libraries so we can have exactly what we want. But for now, here we go. And there is our on-off switch. It's going to come right in here like so. I'm going to click OK. And now that I've got all my parts in here, I'm just going to save that. Because there's really cool versioning in here. So Siren v1, That means if I ever want to go back to V1, I can go back to V1. Now I'm going to start connecting things with nets. Let's move that right over there and keep my nets nice and vertical or nice and horizontal. This bottom is going to be my ground. Everything's going to run along there. You'll see lots of things come down and connect to ground right in here. Again, keeping them nice and straight and clean. Oh, that's going to be a little bit messy. I'll tidy that up in just a moment here. I didn't leave myself quite enough space. And our resistor is going to come over here. I have to click up here to get it to turn the corner in the direction that I want. C1 is going to jump over that. And so in the old style nomenclature that you saw at the beginning, they'd show a little bump where that came up over there. Don't do that. That's old school. We'll just bring it down here and connect to right here. And yeah, I'm going to move that over a little bit, get myself a bit more space in there before I do too much more. This one comes down and connects right here. It comes over, connects right there. That's how we show connections now, instead of having bumps go over top of them. To show that they don't match, we just put a dot to show that they do connect. And there's a net right there, and a net right there. And so I've just got a few things to tidy up down here. So I'm going to say OK to my nets for right now. And I'm going to take a moment and clean some of this up, because in this corner I've got more space than I need. So I'm going to click on the transistor, move it over this way a little bit, drag these corners in so that they look nice and neat and tidy. Maybe pull that up, pull that. Oh, I don't like how that worked out. Let's take, you know what? It's going to be easier if I just redraw that one, isn't it? So let me select this and delete it, and then draw a new net that comes down exactly where I want it to be. And yes, I do want those two to be connected. You have to be really careful about those warning signs and pay attention, because if I'd accidentally drawn that where this net right here was connecting with this one right here, it would have warned me about it. It would have let me make the connection, but that would have royally messed up my circuit later on, and don't think I haven't seen people make that mistake in the past. Okay, and now I don't want to draw nets anymore, so I'll hit the escape key. I'll just take this piece here, move it over there, line that up right there. Then I'll draw a net, bring it up right there. And then I'll take a look to my original schematic and make sure that I've got everything hooked up exactly the way that it's supposed to be. Okay, now if I'm happy with that, I'll click OK right there, and I'll save it once again, because that just takes hitting a button or two, and then it saves a backup copy, saves a copy for you. Okay, now we've got all of our parts named right in here, and what we want to do is we want to tidy up that naming a little bit. Okay, so let's take this and click right on the crosshair right there. Okay, and what we want to do is right click that, and we want to rotate that around, and then we want to keep rotating until it's, oh, there we go, in a nice orientation. And let's take the name. It seems to be want to use G1 for that battery. Let's rotate it, and we'll rotate it around like that. And then let's move that. We're just going to move it right over here. So the part name is right next to it. Our SPST, oh, Click OK. Our SPST switch up here, again, we want to rotate that name around, and then let's move that so that it's just off the board right there, and it's S1. So we'll bring that up right there, and we can even, there we go, rotate that like so. SW1 right over there, that looks fine too. The name for our transformer here, transistor should be down a little closer to the transistor. R1's not in a bad place. C1 should be rotated here. C1's not doing anybody any favors, just sitting there. There we go, C1's now selected. Hit the rotate button for it. Find a nice place to make it say C1. It's going to get crowded if I put it below, so I'll just put it above. C3 is okay. U1, we can bring that down a little bit. R4, could do with a bit of rotation. Put it into the horizontal. Yeah, right in there somewhere. R2 is looking not too bad. C2, let's just take that and move it to the outside of the circuit. This gives us a bit more room to write on it. R3, let's rotate that so it's a bit easier to read. There we go. Oh, and then speaker right here. Well, I think everybody knows that it's a speaker, so I'm just going to hit the delete. Okay, I'm going to have to go in and adjust the properties because I don't want speaker written everywhere when it already says SP1, and SP1 is more than fine for indicating that that is a speaker. Okay, so now we can come in, and for some of these parts we can add some values. Okay, so for R3 right up here, we're going to put a value on it. Now on our original schematic, this one was labeled R4. We don't have to panic about that, but what we do have to do is get the value right. So originally this was a 22K ohm resistor, so we're just going to tap in 22K right here. Okay. And then just hit escape right here so I can get in here, click on this part right here, and when I'm moving it around, I want to rotate that into position. Stop rotating. Go back where you were. There we go. And let's move it. One of the problems with using different pieces of software is that they all have different ways to rotate things, and some of the software I like to use in the past, all you have to do, I don't like the snapping for the alignment on that. It'll work. The software I used in the past, you just had to hit the R key, and I'm sure that's something that they're developing for this implementation of Fusion 360, but it doesn't seem to be working as I do this in the spring of 2020. Okay, C2 is also going to need a value. Now on our original diagram, that was C3, and that is 22 microfarads. So I'm just going to come in here and I want to get off of the move, so I hit escape and I right click on there and I go value, and that will be 22. Now when you're making the circuit, if you put a bigger capacitor in here, that's going to make for a longer as your capacitor discharges. There, that's lining up more nicely. Okay, C2 is 22U in our diagram. Let's hit escape. So we're out of the move command, come in here and value of R2. This was R1 in the original circuit, and it's going to have a value of 120 K ohms, 120,000 ohms. And it would be nicer if, click the move icon, and it would be nicer if the value and the part name were right next to each other. So we'll align it right like so. And I'll escape from move R4 right down here. Properties that was originally known as R3, a 47K value. So value and 47K ohms. Okay, I don't like it right there, so I'm going to move it. Rotate it. There we go. 47K ohms. Our transistor, hit escape. Our transistor right here, we go value, and this is going to be a NPN transistor. So this is our 2N3904 transistor. Okay, and that drew that right over top of there. So I have to come up and click on move. And I didn't want to move the transistor. I wanted to move. Might have to zoom right in to make sure I get the gray part right there. And there we go. And we're going to come over here and C1 now. Hit escape so I'm not moving things around. And change a value on that. That was C2 in the original diagram, an 18 nanofarad, a little 18N film capacitor. And let's move that. And I'm just going to hold it there for a moment, create some space up here so that I can tuck it in. There's a nicer place to put that. Okay, C3 right down here. In our original diagram, that showed up as C1 and had a value of 2.2 microfarads, or 2U2 in our shorthand. So we'll just come in here and go value and 2U2. Okay, and let's see if we can arrange that a little bit more nicely so that the numbers are all together. There seems to be a little bit more open space right over on this side. Keeps beeping at me because I keep forgetting to hit escape when we're all done. Oh, good thing I'm doing this. I forgot to rotate R5's value. So R5 was R5 in our original diagram, and that was a 56 ohm resistor. So we'll add that value as 56R. Okay, and I can move these things around, rotate them so that they're horizontal, and there seems to be enough space right on the inside. Make sure it goes that way. Oh, yeah, there's no other resistors around there, so it's very clear that that's referring to R5. I might want to see. Yeah, it looks better if I bring it in a little bit. I could argue with my snap settings a little bit, but that's coming along okay right in here. And finally, we've got a resistor and a transistor right up here that we want to tidy up a little bit. So let's come in here and hit escape so I don't try moving things, and go value. R1 was originally R2 in our diagram, and it's a 100 ohm resistor. So 100 R goes right there. And let's tidy that up a little bit too by moving this up and moving that up right there. And now we've got most of our values reasonably well aligned. And so our schematic is looking like it should work. We didn't make a join right here, which is a common error in this circuit. And oh, let's see, I don't like the spacing where that says speaker. That should be right in. Let's try moving that. See if I move. I don't want to move it there because that's over top of a line. If I move it up there, it's over top of the net on the other side. So I'm going to think I'm better off bringing that down and just putting it all right off the board. Because if I can't fit it on there neatly, I'm better to just move it a little bit out of the way. Okay, let's see. We should probably click OK. We're not moving things around anymore. And what we want to do is we want to place just a little title block on here saying what this is. And it doesn't have to be anything fancy. So to get our text, we have to come over to the Document tab. And we're just going to click on Text right here. We're going to enter our text. We're going to call this the, oh, it's not the Winky Blink, it's the Siren circuit. It's made by J. Brett in March of 2020. Okay, and let's see. And right down there. That should do the trick. It's nice, it's easy to read, it's clean. If I want to see what it looks like when I print that all out, I can just go print. Got to type it in up here. And the print dialog box pops up. And we can tell it that we just want to send it to a print to file, or you can send it to your favorite printer. You've got a few different options. Whether you want it to be black, fully black text or solid. Normally when we're printing our printed circuit boards, those are things that we want. So for our schematic, we can probably tell it that, oh, well, it's up to you whether you want, if you're printing to a color printer, you can print it in color. We're going to a PDF, so we may as well tell it. Let's turn those options off and see how it comes out if we print it to a PDF. Go OK. And just a moment here, it should pop up. Right, I forgot to tell it where to save that file to. So let's just click right on here and select the folder that we want to put it in. We don't want it in an Electron file output. Put it in somewhere where you want to save it, and that PDF will open up for you, and it should look something. Let me scale that down to zoom to page level. Should look something like that. And you can take that and you can copy and paste it into your handouts or whatever you need for things that you're working on. Okay, let's get out of right there. Let's save it one more time because we're happy. And now let's come back to our project file. So when we're back in our project file here, you can take a look and you can see that we've got a little thumbnail view of our schematic. And so now what we're going to do is we're going to create a printed circuit board to go with it. So you put your mouse over top of the new PCB button, and your new PCB shows up right over here. Now before we go in and start doing anything too much on our PCB, there's all our parts right there. If you want to make them a little easier to see, just pick them all up and drag them and put them into the middle right there, and you can see all those lovely air wires that we're going to have to route. Before we get doing too much right now, we need to set up some design rules. So anytime you're creating a board, you want to come into the rules and you want to click on your design rules. Okay, so this window shows you what all your different design rules are. And the first thing is it talks about layers. Since we're making a single-sided board, we only want the bottom layer, and the bottom layer is called 16. And you can see when we did that, it got rid of the vias, and any through holes in there are just going to come straight down here and solder to the bottom layer. and we've got about 35.035 millimeter thick layer of copper. That makes sense. For more sophisticated designs, you need to worry about that more because it'll do more calculation for you. All we care about is that there's some copper on there. Now we'd also like to make sure that we leave ourselves plenty of spaces between our traces. So let's take that up to at least a 15 mil gap. In fact, we can probably get away with telling it that we want a 20 mil gap. And that's the spacing between wire and wire. And between pad and pad, we'd like to take that up to ideally probably 20 mils as well. We don't have any vias on our board, so that should be fine. Distances between objects and signal layers and board dimensions between drill holes, 40 mil should be fine as a minimum distance in there. Sizes of our traces, we would like to have a minimum width of at least 15, but since we're making this for student use, let's set that to 20 mil. Okay. Our annular rings here describes the size of the amount of copper that's left at the top of a pad. Ideally, what we'd like to have is at least 20 mil, and we could go up to 30 mil if that's allowed. And percent of the drill hole will go to 50 if that lets us do it. No, sorry, I entered that for the top layer. We want that for the bottom layer is where it matters. And we don't have any vias or micro vias to worry about. Shapes that we're dealing with, we're not working about surface mount devices, and for our pads, we'll use the parts that show up in the library. We could go back and redefine them, but we're not going to right now. Supply, you don't have to worry about that. Masks, we're not making any. And miscellaneous, we should be fine right on there. So let's go ahead and just apply all those rules. Okay, and once those rules are applied, we can come out of here, and that'll just help us check to make sure our board is working out okay. So now we need to sort things out, and this is one of those neat circuits that actually the circuit board is probably easier to route if you follow the layout of the schematic. So we're going to come in here and let's pick up this 9-volt battery. We come back here to design. I pick up my move, and we're just going to start moving things around. Let's put that battery into place. Now the battery says it wants to go up to this switch right here. And I'm going to rotate that switch a little bit. Let's rotate it 90 degrees. Oh, I want actually, that's not the rotate that I want. Now, one of the things you want to be really careful about in here, it gives you the options to mirror things. Don't mirror things that have more than 2 pads, because when you start doing that, then you end up with, rather than just rotating them or flipping them, you're ending up with a whole host of other problems. Okay, and there we go. That comes in right like so. We need a transistor over here somewhere, and that is going to be this transistor right here. And we're going to rotate that transistor. No, because you can see the air wire right here from our emitter. Okay, we want the emitter to be connected to that switch right up there. So we're actually going to rotate that right in here, and that helps uncross some of those air wires. Okay, we're getting a few things into place here. That next transistor is going to come down over here somewhere. I'm just getting it out of the way for right now. And our push button switch, that's this one right here, is going to be up in the top somewhere. It's going to be a little after that transistor. That transistor can sit right in there, and this switch can sit right in there. Now I know it looks like that line's crossing, but it's going to be able to come up and go around like that. We should be just fine right there. Let's see, so let's see, the next thing we'll take a look is coming off the base of the transistor right here. We have a line that comes down here and it joins to this resistor right in here. I don't want to move its value right at the moment. I want to move the resistor, and I'll bring that resistor right into there. There's a few other things in the way. This 120 k ohm resistor right here is going to come down to this side. This 22 comes over to this side. The speaker comes over in down here somewhere. The 56 ohm resistor comes down here and rotates 90 degrees. The speaker can be rotated 90 degrees too. There we go. That lines up fairly nicely. And again, the speaker is going to be up on the board, so we just need those two holes. We could overlap things in there if we wanted to without having a problem, although the computer would probably complain about us doing that. Let's see, what else do we need to move around right in here? This capacitor is going to be, it's one of the two little capacitors, so one comes down in here. This one goes right down, and you can see the bottom right there is going to come around and connect to right there. So let's rotate that. I want to rotate it a little bit further. There we go. Now the bottom side is right down there. And let's see, that 47 k ohm resistor, where does it want to be? So I'm looking at the air wires and saying, oh, that wants to be down over here somewhere. And it looks like one side of it's going to come down to the negative side of that cap, which touches the negative side of that. So let's rotate that so that that is all the way down. Okay, this capacitor comes up over here somewhere. This capacitor is coming down over here somewhere. And if I'm going fairly fast, yeah, I've done this board before. And let's see, right in here, this transistor is going to need to rotate. The base is going to be connected to a resistor over on this side. So let's rotate it 90 degrees and put it in right over here. Okay, so now we've got some of this cleared up a little bit. Going to be some tight etching between those pads in there, but I think we can get away with it. And let's come in here and start doing some routing. So we're going to do some manual routing now. And let's set our trace width up to, oh, I find 20 works fine for shop etching. We could go up to 24. There's no reason why not. We got lots of space on this board. And let me undo that right away. You saw that came out in red. And if you're doing a single layer board, think of red as a warning. It shouldn't be letting us put anything on the top layer because we turned off the top layer, but we turned the top layer off after we already had it showing up there. We want everything nice, cool blue right up here. This is going to come along and we're going to give ourselves a little bit of space right up here. Bring this over to here and right in there. Now I'm just going to move a few things around. Well, I'll move them around in a little bit. Now you can see this air wire right here says that this is part of net 3 and this is part of net 3 and this is net 3. So it's telling you that it wants to connect right there. That's not actually the easiest way to make that connection. The easiest way to make that connection is to do a manual route, and we're still in manual route mode, from right there to right there, because now that's connected into net 3. And coming off here, I need to connect that to that resistor. Now I could come straight down, but that puts me a little bit close to that pad right there. So I'm just going to come out here a little bit and come down this way and give myself a little bit of gap right in there, just because I know that if I'm going to have students doing soldering on this, that I like to give them every chance I can to not botch it. It doesn't always help, but it's nice to think that you at least tried. Okay, then I'm going to come down here. May as well connect some of the easy ones while I'm at it. And there's lots of lines coming in here saying these all want to connect together, but you'll see N6, N6, these are all tagged right on here. And there'll be easy ones to connect right there, and that updated right there so you can see that that's going to run along at the bottom just like we did in the schematic. Put that connection in right there. We'll tidy some of this up and make it look a little bit neater later on. And let's see right here, this capacitor, I should have moved that and rotated it into place when I was doing my moving. There we go, put that down on the bottom right there. And that can come in about like so. And while I'm in a move mode, it looks to me like this one right here is probably going to be happier if I rotate it. I gotta click on the middle of it right there. Oh, I wanted to rotate it 180. 270 from where I was at. There we go. I think that's going to make for a happier resistor. And then this one right here. And come in about like so. Fit in about like that. And then this capacitor, I guess it can go just about anywhere. If I was to bring it right up around here, this is a bit of a deviation from the circuit board design. I'm going to actually rotate it back the way it was, I think. Nope, I want to take that to 270. So right in there, so that's going to come around. I can tuck that right in there. That looks like I should have some fairly compact connections. So now I can come back to doing some of my routing and manual route. This one right here is net 4 to net 4. This one right here comes down right in here, going to come right across like that. This one's going to come out and down, all the way around to over here. This one's going to come right to there. It's going to come right to there. This capacitor is going to come in and it can connect to any point right on there, I think. I'm not going to do that one just right at the moment. I'm going to do this one right from here to here, because that's going to let me get a nicer connection when that comes in and joins in right there. This one down. Ooh, this is a little bit of a tricky route right in here, because now this one wants to come up to that side of that capacitor. This one wants to come down there. I'm just going to wait for a moment and play with that. This one right here is not a problem. You can see it wants to come underneath that resistor, and we can definitely route underneath a resistor and bring it down like that without any problem. And right in here, this one's going to connect right to there. And over here, if I take a look. Where is that connecting to? So that one is the emitter. Well, interesting. It's a good reason. This is as good a reason as any to manually route your boards instead of just using some fancy auto route feature, is that sometimes you find little discrepancies in here. And apparently that TO92 package that we used was not for a 3904 style or a 2222 style transistor, but maybe more for something like a BC548 transistor that goes collector base emitter. We're used to the transistors going emitter base collector on a lot of the ones that I have in my shop. And this transistor is actually flipped from what we normally use. So if you'll recall, I told you to be really careful about not flipping components. Well, we can flip this one around and turn it into a 3904 by, let's get out of that route mode, and I just want to take this one right here, and let's use the move command for it, and it lets us mirror. There we go. We've mirrored that around, and now I'm just going to drop that back in here. What it's done is it moved some of the pads up to the top layer, which is going to be a problem. We're going to need to figure that out and route around that in just a moment. I'm also going to take a moment to rotate it 180 degrees from where it is right now. Actually, I'm just going to take that and there we go. Get that completely out of there. And now what I want to do is use my move command, and I'm going to take this and not move it anywhere. Just rotate it 180 degrees. So that's back on that side. And now, if I look at it from the front, our emitter, which our schematic clearly shows should be going down to the ground side, is facing on the right side. Our base is still facing over here, and our collector is right over here. We just want to get rid of this one line right here, and let's delete that. Okay, so good thing that we check this and go through manually and know what parts we're wanting to use. Gave me a chance to show you the flip command and why you almost never do it. It looks like it flipped the text up onto the top layer for us as well. Let me bring that back by using the move command, and I'm just going to flip that text. Let's mirror that text. There we go, so that that's back in the correct orientation. And let's rotate that around. Not that this matters a whole lot, but there we go. We're in the same orientation as everybody else. And right on here, we'll take that name and we'll mirror that and rotate it 90 degrees so we're on the same orientation. So our documentation is easy to read right here now. And there we go. Now we can go about finishing up our routing right on here. And we're on the bottom layer, so we can sorry, I'm still in move. I've got to pick my route command, come in here, route that right in there. This one right here is going to come up, navigate underneath that capacitor, and right up over to there. And from this side right here, come down, connect right there. And we'll just route this one down here. It's from net 6, so let's manual route that away from there and bring it down to ground. And that should connect it together right into there. And that looks to me like we've successfully routed the one more right in here. Route right across there. Now, a couple of things that you'll see that make this routing successful and that make it work is we're not trying to cram any lines right through in between spaces like inside the transistor where they're not going to fit, or underneath these little capacitors where they're not going to fit. In fact, we're probably getting some errors already telling us that these pads are a little bigger than we'd like to have. It's always one of those trade-offs when you're putting a small device onto a board. Ideally, for grade 8s and 9s, we'd space those out just a little bit wider. Their capacitors and transistors wouldn't sit quite as flush to the board as if we had them in perfect spacing, but this will probably work for us making this in our shop. Okay, now that we've got all that done, we want to do a design rule check. So come on in here and let's check for errors. And let's see what it says. Oh, we need to clear all the errors. Let's clear that list. And then let's check for errors. And when I cleared that list, I didn't get any. So let's come in here, do a design rule check, apply, do a check. And it tells me I've got 6 clearance errors. So if I click on that, you can see that area was already highlighted in blue. And we knew that we were going to have a clearance error right down there. But if we're careful about it, we can etch that, so I can live with that error. Again, same thing right there. Where was that next error? Right in there, right in there, right in there, and right in there. So not ideal to have those little errors on there, but we know about them. We can be aware of them. We could go in and we could play around with the pad sizes and change that up, but by and large, this is going to work for us. Now, a couple of things that we can do to wrap this up is we can try making it a little bit smaller, because if we save a little bit of space on our footprint, then that's just more copper to save. So let's come back to our design tools here, and let's move this device right over to here. And again, that speaker's not really there. We can move it in a little closer right here. We can move this in a little closer right here. Oh, I don't need to move that. I want to move this down a little bit right in here, which lets me move. Oh, there's my 100 ohm. Move that down right in there. Move that down right in there. Move this down right into there. Looks good. This can come down. Yeah, probably being a bit fussy putting it all the way down there. This one can come down in here a little bit. That can come down. That can come down. Let's see, we can move everything inwards a little bit too, I think. So if I bring that back right to there, then I have to bring this line. And you can see it's giving me warnings right there in blue. It's telling me, oh, you're crossing over another part. Those warnings clear up when I get rid of that. Bring that transistor in right there. Bring that line in like so. I'm going to bring that part down about like so. Just get it out of the way and get it away from some of those pads. Bring that in. Is that never properly connected before? That's net 1. That is supposed to be connected together, so somehow that didn't stick when it got manually routed. So let's join that together. So I've done my routing. Let's go back to my moving. This can actually come in even a little bit closer here, because it's okay if that goes over top of that line. That line is on the other side of the board. Same thing right here. This could come in and route a number of different ways. It could sit right there. I'm thinking this capacitor is no longer in its optimal position right there. We can probably bring it down right into here, and we can rotate it 90. Now this creates a little bit of a mess right in here, so I'm just going to tidy this up and reroute some of this. Delete that. Tidy all that up right in there. And now I'll manually route this side right in there. And then that one right in there, because before it was kind of pointless. It went up here and then came back down that way. So just with a few little tweaks like that, we made it smaller without creating any significant problems. So now what we'd like to do is give it a couple of mounting holes on here that are going to be easy to see. Now, if you're having one commercially manufactured, they have tools to put drill instructions on here so that somebody will actually drill a hole of your desired diameter on there. Instead, what we want to do is we're just going to draw a circle on the copper layer so that we can put something in there. And so we're going to document it, and we're going to draw a circle. And let's see, a mounting hole could go right here. And a mounting hole could go in the opposite corner. A little board like this probably only needs 2 mounting holes. And we don't want to have them over top of the circuit. There we go. So we've got that all put together right in there. And somewhere on here, we should probably also put our name saying what the circuit is. So let's just say that's okay. And let's put in our name that's under document and draw text. And we'll just put, it's not a Winky, it's a Siren. There we go. And let's bring that on here. And I'm just going to change that size down a little bit. See if I can tuck it right in there. And that looks like it should fit fine. Okay, and of course we're looking at the board from the top, so that is going to look reversed, but when we flip over the board and look at it from the bottom, that's going to look perfectly fine. Taking one quick look right here with my editing, net 7 right here ended up running into net 9. That's not very good. I probably would have caught that with a design roll check. In fact, let's see what happens if we do a design roll check right now. DRC, check. And let's check for clearance. Double click on that. We know about that one. We know about that one. Aha, that's one that wasn't there before that we didn't know about. Let's fix that by coming back to the Design tab, doing a little bit of a move in here. There we go. Okay, let's come back to our Design Rule check, check. Not a problem, not a problem. Oh, there. Yeah, we know about it, we know about it, know about it. Then it just gives us a warning that it says no vector font. Quite frankly, I don't know what that error message means, but I'm not worried about it. Okay, there we go. Now we've shrunk our board quite a bit, so we can come in here and come back to our design, and where we've got the Move tab, let's just bring our board edge in to right here, and to right here. And as we're bringing it in, you can see that we're changing the size of our printed circuit board, getting that size down nice and tiny. Good idea if you can try and keep it square. And our board information is now 1.982 inches wide by 63 millimeters high. Very Canadian measurements in both units that are standard in North America. Okay, there we go. So we've got this looking pretty good. I think this board's ready for production. The next step that we do, we could do a few things. We could chamfer this corner right here so it didn't come quite that far out. We could chamfer that. There's a few things we could do to make it look even nicer, but this one's probably ready for production. And so we can type in print, and the print window will pop up right here. Now, you don't want to print all of this information out, okay, because there's way too much on there for your toner transfer. So let's just cancel that. Before we come to print that out, let's take a look at which layers we want to have displayed. And let's go hide layers. So everything's disappeared. And then all we want to do is we want to turn on the bottom and we want to turn on the pads. Okay, and with the bottom and the pads turned on, when we print this out, that's all that's going to come out, so we can toner transfer that. And this will make a useful toner transfer for our bottom copper layer. And that's what that's going to end up looking like right there. And we don't need to mirror it because that will happen automatically. Scale factor has to remain at 1. Okay, we want it solid, we want it black, and we go ahead and we click OK, and that will kick out for us. Now, if you want to send it to a PDF, okay, you can also do that and kick it out directly to PDF. And we can take a look at it a little bit closer up if I remember to tell it which file we're saving it to. Let's do that again. Print. Okay, output file. And it saved it to this file right here. Let's open that up. And there is our file right there. We're zoomed in right there. But you can see we've got transistors, capacitors, and it's solid and it's black, and all of our nets are isolated as they should be and only connected to the things that they should be. So that's all looking pretty good. Our file is now done, and I'm going to hit save, and I'm going to make sure that I remember to call it the Siren. If I come back to my main project right here, there we go. We've got a thumbnail view of our board, a thumbnail view of our schematic, and we're all ready to go.